everybody. We are starting. Please be quiet. Couple of things. First of all, welcome. Here I am to introduce our next speaker, Pavlo, in our PostgreSQL devroom, who's going to talk about Go. Just a few practical things. When you exit, please exit from the back. And if you want to go out in between the talk, please be quiet, because this devroom is very loud and these chairs are very squeaky. So, yes, that being said, enjoy.
Hello people, how are you today? Was yesterday fun? Because first two talks were not really crowded, but mine is good already. Yeah, my name is Pavlo Golub, I'm working for Cybertech. So I'm a senior consultant in a body of a young developer. Today, well, a couple of words about my company. Cybertech is purely PostgreSQL company. We work with clients only if they have PostgreSQL. If they don't, we install it, and they can work with us from that point. We are having several branches all over, not all over, but the world. Some of them in South America. Most of them are in Europe. Not now. Wanted to restart. So some of our customers, so choose your fighter. Some of our products. So we're not only consulting people, but we do products. Yeah. Why PostgreSQL? You know why. It's cool. Absolutely. So I'm talking about today. So first of all, I want to introduce you to the Go language. How many of you have an idea what the Go language is? Okay, so I don't need start from the beginning explaining what the compiler is, etc. So yeah, okay. Then I will say a couple of words about IDEs and editors we are using. Then I will describe drivers for PostgreSQL specifically, some useful extensions, how we do testing, how we do releases, how we do continuous integration, development, etc. And then probably, I hope, we'll have a question session. Okay, so why Go? First of all, when I start my first project, I like that Go produces the native one binary for every platform. I said, wow, I just can build everything from the same command line for every operating system and architecture I want to. And I don't need virtual machines and other crap, just like Go. It's simple enough. It has a good community. It now has already very comprehensive tools, support by GitHub, GitLab, etc., etc. Yeah. So cross-platform is somehow connected with the native binaries for every architecture. So this is the last developer survey for Go, asking how people are using Go language for what kind of. So speaking about Postgres, I would say that data processing is somehow connected. Before that, we had like these answers, where you can see that databases is like a half of the projects people were using. Probably you know, if not, so the top products written Go are Kubernetes and Docker, OpenShift, then Hugo, the fastest framework for building statical sites, etcd, etc., etc. Postgres-related Go products, which Go Postgres related, which are written in Go, are the CockroachDB, both Postgres operators from Zalando and from Crunchy, WolG, PG Center, PG Watch, PG Timetable, so on and so on. So if you want to find more projects, more applications written in Go, please go to this site, to this repo. There are a lot of them, yeah. Okay, so what about tooling? Because when I was started, I used Sublime Text. There was no proper IDE to work with, no debugger, no these kind of things. Right now, according to the last year developer survey, the most used IDE is VS Code, then Goland by JetBrains, and then Vim, and Sublime Text is 1%. I was saying at the conference, at the talk, that I will try Goland and will tell you about how it is different from VS Code. No, still didn't try it, but I think it's good. So these are the answers from the previous years. So as you can see, the intention is the same. So VS Code on top and Go language, and etc. Goland, sorry. What I'm using VS Code with the official plugin installed. Then I'm using tparse command line utility to make these fancy tables out of test output. Linter, of course, tab9. I tried GitLab Copilot. It's not bad, but I don't want to spend my money on this. I have my own head, you know. Go releaser to produce the packages and binaries like in one go. Then PostgreSQL, of course. And the last, but not least, the Gitpod.io, which is pretty much the same thing as a GitHub workspace, but it's free for open source developers. So it's good if you want to try something new and you don't want to install everything on your machine or to set up the virtual machine. You can go there, run it in your browser, drinking beer on the beach and trying something new, right? It's okay. If you're done, you just close your browser, close your tab, and it's gone. Now, about drivers, about the PostgreSQL part of this talk. The whole idea of this talk started after I tried to find a good tutorials about how to start to work with PostgreSQL. A lot of them, not all of them, but a lot of them say, okay, just use ORM and you're fine. Well, why? If I need to create utility to use 3 commands, right? Why should I use ORM? And yeah, don't get me wrong, ORMs are fine if you know what you are doing. They solve the problems, but you don't need to put it everywhere. And you don't need to start from it. Because otherwise you will be learning ORM, but not learning PostgreSQL itself, right? Yeah. We have SQL for that. So during this talk, I will not be explaining ORMs and how to work with that. I will explain the basic drivers. Anyway, ORMs are using drivers on the low level to speak to the PostgreSQL, right? So we should know how to use them. So the thing is in Go that we have these database SQL interfaces. Interfaces is just like an agreement on what methods are available from, I don't know, from object, from structure, or whatever. And for each database, there should be a special driver, an implementation for this interface, right? So the first official implementation for the PostgreSQL in the Go world was libpq. It's good, it's proven, it's a long time on the market, but it is in maintenance mode right now for 2 years probably. It's not bad, it's okay. You can be sure that this functionality is solid, but if you want more, and if you start a new project, JAX-C PGX is the way to go. Because you can use it with whatever you want. I will show you later. So yeah, we are scientists and we do graphs. So unlike of Python, or not in Python, but in PM, JavaScript world, we don't have this statistic for how many times particular package was downloaded, used, whatever. So the most funny way is to use GitHub stars and yeah, to build this stuff. So as you can see, the PGX is 1 year, started 1 year later, but now it's going to be very popular. So in 2019-20, there was an announcement that the libpq is going into maintenance mode and the PGX started to grow. So what if your project is using already database SQL, or you want to follow tutorials or techniques and to use this database SQL standard de facto interfaces? For that purpose, PGX has a special wrapper. So you can still use database SQL interface, but you can, underneath, on the low level, you will use the PGX package. So you should use PGX solely if you are starting a new project and your project is aiming only PostgreSQL, right? Then you don't need database SQL. But if you are like dependent on ORM, or you are dependent on other package which want you to use database SQL, right? You go for wrapper. In that case, the dependency will use this wrapper to speak to the database SQL, and you will use the power of PGX. So there are a lot of unique features that are not present, not implemented in the standard library, and they cannot be implemented because this interface is common, is the same for every possible database. So for example, you cannot add methods with a copy support because only PostgreSQL do copy support, right? So the most cool features is that PGX supports binary transfer protocol, and it supports natively all built-in Postgres types. And if you create user types, it will support them out of the box unless they are very complicated. But even in that case, you can create a special interface, a special object structure that will tell PGX how to encode, decode the values of your types. So as I said, yeah, copy protocol, logging, yeah, and for connection pooling, you have this after connect hook. So the idea in Go language is that the database object that you have is pool by default. So it can like create additional connections, and you never know how many active, well, you can know, but you can never tell how many connections you have right now. And this, for example, after connect hook helps you to prepare your session, prepare your new open connection for something, like add some identifier, login, or whatever. Yeah, listen notify is implemented natively. What else? Yeah, different JSON HStore, large objects. So everything you need is already there. Nice thing about PGX is in December probably the new major version 5 release was and it was a huge step forward, especially in the term of dependencies. V4 version 4 was good, but it has so many external dependencies that, for example, Magnus Agander said, no, we will not rewrite our internal tool into PGX because it's too much dependencies. It's not the thing anymore, and it's very cool. So yeah, hello world. You probably all know how to write it in the database SQL. With the database SQL interface, so you're just using that import package, but instead of using libpq, you are specifying PGX std_lib, which is a wrapper for the standard library. And then all things are the same, no difference, no difference. So if you want to update your project, you just change the import part, the import of libpq to the PGX standard lib, and you are fine. If you want to use PGX directly, you are fine to do that. The thing is here that the PGX return, the connect method return the one connection only. So if you don't need a pool of connections, or if you want to be sure that only one connection is alive, one connection is used, you are going with PGX Connect, right? But please remember that you cannot use this structure, this connection, in parallel. So you need to know that at one point in time only one thread or one Go routine can talk to the database. Otherwise, you're good. But if you want a pool of connections, you are going with PGX pool. And I don't know, what can I add here? It's obvious. So yeah, it's pooling. You can pass it to the Go routines, and it will create additional connections as you go, and you can limit upper number of connections, etc., etc. It's very, 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 very flexible. Okay, about useful extensions. For my first project, I started with the libpq as well. It's the way to go. That's how we grow. And later, I understand that I want this copy functionality badly. I need that. So I started to look to the PGX, how to switch to it. And I didn't want to lose these SQL things. When you're encoding, decoding your structures, slices, arrays, whatever, right from rows or to rows, right? That's what most people think the ORM do. It just translates the rows into the structures. But yeah, it's very useful. So like, if you are working with the old database SQL or libpq, you are importing this SQL thing, and you can have a lot of new methods, like you can struct the row into the structure, or you can scan the scalar into the variable, or you can create a slice from your rows, etc., etc. It's very cool. PGX at that time didn't provide that, but with the latest version 5, everything is already there, better is included. probably you can find cases where you want more control over decoding and encoding, but after this guy was introduced, row to struct by name, written by me, by the way, yeah, everything became very easy. So before that, we had only row to struct by position, right? So if your structure fields are in the same position as your field in your row result set, you're fine. You're just like doing the back and forth. But if you want to skip some fields, or for example, if you have some non-public fields in the structure, but still want to use this functionality to decode and encode from the result set, this is the way to go. Yeah. Now about testing. We all know it's very essential, right? And I heard a lot this statement that you need to write your tests first and only then implementation. I never did. Maybe one of us tried it. Oh, go. I'm too lazy. Because I never know where at the end I will go with my code. I'm starting like, okay, I will implement this thing that will return this integer, and then oh no, let's do this CTE with a lot of things. Yeah, and if I write a test before, I need to follow it, right? No, it's not funny. How we do testing? So I would say there are three main approaches. The first one, obviously, is to start a real PostgreSQL server. You can have your local installation on your test environment, or you can download it during the test running, install it, initialize, etc., then cache. But it's still the same. It's a real PostgreSQL server. The second approach would be mocking libraries for database SQL. That would be Datadog, Go SQL mock. And for PGX, I created this PGX mock, which is the brother of the SQL mock, but yeah, works with PGX. I hope you know all what is mocking and how these things are working, right? So, yeah, we are pretending that we are a PostgreSQL server, and our application, our tests, are thinking that they are speaking to the real server, but in fact, we just throw the needed answers to the application. So, do you need rows? Okay, this is row, this is row, this is the answer. Oh no, that was a row. Let's see how you will react on that, etc., etc. But if you want to test on the protocol level, there is also some very low libraries like pgmock, which is just like the real low-level mocking protocol. CockroachDB has its own test server, which you just like can import CockroachDB test server and use it in your tests. And another library is Copyist. Okay, let's try to maybe. It's not very useful. Now let's get back. Can it work? Okay, so how to create a test? How to use this PGX mock thing? So if you read the README on the repository, you will see that no changes required to your application. That's a lie. You need to provide an interface, because the PGX return structures either connection or a pool. We cannot mock structures. we can mock interfaces. So I'm defining pgx eFace interface here and say to my method, to my function, that I will use this interface. Please use that. And for my function is like, it doesn't care would it be a real connection or would it be mocking or anything. It just knows that this object has this methods, and it's enough for that, okay? So yeah, we write the code, kind of shitty, but okay. We're trying to commit, we're trying to roll back, etc., etc., etc. How to test it? So I always start with the successful test cases. I'm a very positive person. First thing first, though, I'm creating the mocking object, pgx mock new pool. Then I will tell my mocking object how should my session looks like, right? So I'm saying I'm expecting that we will start a transaction. I'm expecting begin. Then I'm expecting that the code will try to execute update statement, right? And when this happens, please return to this code the new result that update was successful and we updated one row, right? After that, I expect that the code will try to insert something, and I expect that the arguments for this statement would be 2 and 3. If that is the case, please tell that everything is good. We insert one row. And after all of that, I expect that the code will commit the transaction, right? That is what I'm expecting from the code. Then I'm calling my function record stats, and instead of the pgx, I'm passing the mocking object, mock, and 2 and 3 arguments, right? And if anything goes wrong, the test case is failed, right? But another thing I want to check, if every expectation I set were met. For example, after the commit, my code might want to write a log to the database or do other things. I don't expect that thing from it, and these expectations were met will fail if something else is happening inside this function which is not being expected, right? So for failure is pretty much the same. We are telling that we expect to start transaction, we expect to start update statement, but let's pretend we want to test how our code will behave if the insert statement will fail. So we are telling, so when insert statement is coming with the arguments 2 and 3, let's pretend that error happened. Return error to our code. And the error with some error text, but very beautiful. We are starting our function, but in that case, we know that it should fail. That's why we are checking our error to be not nil. We are waiting error, right? And the same for expectations were met. So, for example, if we failed and our code tries to do more than we are expecting, we say, no, please don't. Please don't. Yeah, so, and then you are just using Go test and with the tparse thingy. I just love how the tables look after this output. So, like for this case, we have like one package, and we have 2 test cases, right? But in real application, you might have hundreds of test cases and dozens of packages. They all be listed, and you can see a coverage for every package, and you can see probably coverage for every test case, how many passes, how many fails, etc., etc. Also, you want to probably investigate what is the coverage. For that, you are using the built-in Go tool cover tool that will produce temporary HTML files and will open them in your browser. So you see a combo box with the list of files in your application, and you just go through all your code. The red one is not covered by our test cases. The green one covered by our test cases. For example, in this case, our main function is not covered at all because it's tricky to test the main function. That's why you should put it outside of everything and make it like 2-3 lines and only use your packages inside. Okay, so time for continuous integration and continuous deliver. Yeah. So we are working as a company. We are working in GitHub, but I'm pretty sure that the same functionality is available on GitLab and Bitbucket and on everywhere, right? So for every my project, I want to have at least 5 actions, GitHub actions. First one is a dependabot. I want my repository is constantly being checked if any package I'm dependent on is updated, right? So it will update, okay, we have a new minor or whatever version of this package. It will automatically create the pull request. I will check the output. I will check if tests are fine, if everything is okay. Okay, very good. I like this, because you can do 3 pull requests per day and you are super productive. Then what I want to also always have is a code QL, which will build your sources and will investigate the possible security vulnerabilities. Build and test, I'm using that for pull requests only, because if you are firing them on every push and the test is heavy, it's not fine. Release will produce the binaries and packages when the new release is created. And the Docker is the same, like for release, it will produce a special tag and an image and push it. But for every commit, it will produce a special Docker image, which you can just try immediately, right? Like a night build or whatever. Yeah, so dependabot is very simple. For example, for almost all my repositories, I first want to check the Go code itself, so package ecosystem Go mode. And I want to use the latest GitHub actions as well. That's important. So I check it daily, and that's usually enough. For CodeQL, nothing special. When you create these actions from the GitHub interface, it will fill all the fields for you. I never changed very important thing there, only removed some comments and we're fine. Build and tests, I hope you can see what is going on there. No? Sorry, I don't want to switch to the editor because I cannot work like that. Yeah, so I will tell you. So I usually run all my tests on 3 different platforms: Windows, Mac OS, and Linux. The good thing is all the workers already have PostgreSQL installed on them, but the thing is that it's not started. So for you, essential is to start PostgreSQL and then run your tests, and you are fine. Usually the version of Postgres is behind like 2 or 3 minor versions, but it's okay. If you want just like use the latest one, you can go with the Docker, right, images instead of that one. Yeah. So there in the build action we have linter. So no, without linter we cannot accept any changes or pull requests. And yeah, and then we are using we are generating the coverage report to put them everywhere. See, 99% of code is covered. Yeah, that's lie. Okay, so release is a little bit simpler. As I said, we are using Go Releaser. It's absolutely fabulous piece of software, may produce everything for everything. So the GitHub action code is simple because everything is stored in the YAML configuration file where you set up the names, the architecture, the OS, everything. And then you just like, okay, let's check out our code and let's release it. And the cool thing about this is the Go Releaser will create a changelog automatically for you based on your pull requests. So when I'm releasing, it's just like I copy paste it, just sort it about the by the like what added, what fixed, and whatever, and I'm done. The release is very simple for me, absolutely. Before that, I spent 2 days on each release to produce all these binaries, etc., etc. Okay, Docker. Go Releaser can produce Docker images. I'm too lazy to rewrite this. And yeah, I'm using like another special GitHub actions to build a Docker. You can build them for every possible platforms, and this Apple M1, M2 Silicon thingies, whatever. It's just working. Okay, takeaways. The Go is popular. Devroom doesn't like Go. Yes. So maybe this is the last time you see this talk, like when everything goes right. He said that I need to switch to Rust. So maybe maybe next FOSDEM I will go out with when the Rust goes right. Or no? Should I stick to the Go? Okay, we can do both. Yeah. So a lot of developers are using databases with Go, of course. You can use whatever editor, whatever operating system you are. By the way, a lot of people are using Windows, which is not common for like Postgres community, for example. But it's fine if your system can produce whatever you want. You don't care. You just work on what you have, right? So Kubernetes. You can use whatever you want with the Postgres. If you want to use ORM, please do, but remember, you're responsible for that. Use it wisely. Otherwise, you can use libpq package or new PGX, and you can use whatever GitHub, GitLab, Bitbucket you want. And the most amazing thing about Go is the backward compatibility. You can build whatever in the future, whatever code you want, and it still will be compatible with the oldest something written ages before. Even now, when we have generics, when we have a cool thing is in Go, they are still compatible with that old things. Okay, so yeah, don't be a stranger. Check my GitHub account, check our blog. Yeah, some of our projects. And if you have questions, or maybe you have a question to devroom why he hates Go.
No, I don't hate Go.
Okay.
It's just I don't pick it.
I'm not sure what the problem is. I provide everything you need. Take my binaries and put them in your packaging, whatever.
Distributions don't like to pick Go because either it should be a binary or download internet, which is
Not internet. No, not internet. There are only 4 dependencies for a new created application which uses PGX to connect to the PostgreSQL. There are only 1 direct dependency, is PGX, and there is only 4 indirect dependency. 2 of them are libraries from Google, 1 of them library from Coros, I don't remember, and 1 of them is by the same author because he's using this package in other way. Yeah, so questions? Microphone.
Hi, a couple of slides back, you went to a certain functionality where you were asking, you did select and then you put in a structure in order to get the results from. Like it's slides, yeah, a couple back. I have a question on that one. It's, yeah, this one. Yeah, that
this one?
Exactly. Yeah. So you're asking a select star and then some stuff, and then you ask it by the rows. Does the actual connection, so if you're running this on one machine, you're running Postgres on another machine, there's a network, of course, in between, there's data going back and forth. Is all the data being sent from the PostgreSQL server to your Go program or not? The reason I'm asking this, is because let's say there's a 4th field, which is, let's say, a huge JSON field or a huge binary field, which contains like a megabyte of data per record. Is it then sending, if I'm asking 100 records, 1,000 records, is it sending a gigabyte over the network, or is it only sending those 3 fields?
Okay, I got you. Yeah, thank you. Very good question. So in this particular case, it shouldn't be star, first of all. We should always list a columns we want to have. I'm just too lazy, and this is not my code. But it's like, it shows. Yeah. So in this case, yes. Everything will...
Can you do it automatically? Because if I would do select ID name price, then I would need to change my code 2 times, 2 different places, and probably add 4 fields to it.
Can we do automatically, can we add columns from a database automatically? Yes, we can, but for that we should use SQLC package, which is exactly for that. So it uses pre-built or hooks or whatever. So when you say go build, you have a special like SQL files. Like I want this field from that and that, and it will go through it, and it will build automatically the appropriate structures for Go, and then you can use it. Yeah, it's just a lot of information. I cannot like put it into the one talk. Yeah, but yeah, about if we are loading all at once, yes, we do in this case. But the Postgres protocol itself supports row by row functionality, and it's possible to use that functionality with this package. So you can say that.
Hello, thank you for the talk. I have one question about this driver. Actually, it's kind of only way to work with Postgres, for my opinion. And I'm a little bit worried that this driver is not supported by Postgres community, let's say. It's supported by someone. And what is the life cycle of this software? And maybe it will die, you say. How is about new features to add? And all this question arises when you work with it, because if your management says, okay, let's use Java, and in Java it's kind of stable, this Postgres driver, and you know that you always have the new version. What is about this software?
Yeah, thank you for the question. So versioning and owner, who is owner, and that's kind of stuff. So as a PostgreSQL community, we support on the C library, which is libpq, and Java, which is JDBC, right? That's all. All others, yeah. Who uses C++? Okay, so all other libraries are maintained by someone. By the way, libpq is not a standard library in terms of made by Go. It's also maintained by one person. So how we do in this case, we just fork it and use it if you want something new. If I did everything better, then the maintainer, the owner of the PGX will accept my pull request proposals and we're synced, right? If not, I will beat him and I will be popular.
I have a question regarding testing strategies and CI/CD. So you have shown that it's possible to mock PostgreSQL, right? But sometimes you are relying on some feature of PostgreSQL, or possibly you are relying on some extension Postgres. You want to test with a real PostgreSQL.
Yes.
What you can recommend? So I have seen in your CI/CD you're executing some PSQL commands. Do you have a dedicated instance for running tests, or are you using
no.
containers?
My GitHub actions are using pre-installed PostgreSQL on the GitHub workers. They already have like Postgres like 15.1 probably nowadays. So I'm okay if they are behind like several versions. I don't need to test for a specific feature or a bug or whatever. But if I want to, in my GitHub action, I may specify the Docker image against which I want to test. So for example, if I want to test the latest master from the PostgreSQL community, I will build my own image Docker and will run my test against it. And I'm fine. Okay, thank you.
Please exit from the back. Yes. Careful, there are cables. Don't.